In this recording, we're going to learn about the complex roots theorem. First, we're going to understand the theorem, where it comes from, and then we're going to apply it for an example where we find the fourth roots of 81 cis 120 degrees. In other words, the four numbers that you could raise to the fourth power to come up with this complex polar number. Okay, so we're going to build it on Dubois Theorem, which told us how we could find powers of complex numbers. Now, of course, a power that is a fractional exponent is a root, right? I mean, we could have something, for example, I'll just kind of put it over on the side here. If I wanted to do x to the 1/2 power, that's the same as the square root of x. Or if I wanted to do x to the 1/5 power, that'd be the same as the 5th root of x. I think you recall that, right? So let's apply that here. I'll kind of get rid of that work over on the side here. So here's the theorem. Okay, so we have a complex polar number in our regular form. You could write it as r cis theta. And we want to find the nth roots, where n has to be a positive integer, like 2 or 5, like we showed with the x. Then the n distinct nth roots, just like there's 2 square roots, right? And there would be 5 different 5th roots. Well, if I wanted to find the n distinct nth roots, this is how it would come out. Let's call W one of those roots, okay, where k is the subscript. You can have k different roots, and we're going to talk about what k can take on. And it's going to look like this. R to the 1/nth power, again, that could be written as, I'll just make a little note, that could also be written as the nth root of r. And then we're going to multiply that r by cosine of this angle. Now, this angle might seem unusual, and we'll have to kind of unpack where this came from, times I sine of this angle. Okay, so the angle is this. You're going to take your theta plus 360 degrees times k and divide that by n. We'll talk about why that is. Okay, so first off, where does this come from? Well, we know from Dubois Theorem that if you are raising, for example, r cis theta to the nth power, what we would do is do r to the nth power and then cis of theta times n, right? Well, what if n is a fraction? Well, then we'd have r to the 1 over n, right? And we'd have to multiply theta by 1 over n. So essentially we're dividing by n. Okay, so that's where it comes from. It comes from Dubois Theorem, just an extension of it into fractional exponents. However, there is a little bit more to it because, well, when we divide theta by n, there are multiple places where, given different values of theta, so let's say instead of just having 100 degrees, you went around a whole rotation plus 100 degrees. So you'd essentially have 460 degrees. Well, that's going to lead you to the exact same place on the polar plane, right? So we need to take that into account. What we need to say is you can have multiple trips around, coterminal angles for that theta, for various values of k. Okay, in other words, where k is equal to 0, 1, 2, all the way up to n minus 1. So if we're speaking about the nth root, you can have n of these because we're starting at 0. So for the one we're going to look at, looking at the fourth root, so you can go, k can be 0, it can be 1, it can be 2, it can be 3, all the way up to n minus 1. Okay. So again, we can add on 360 degrees n minus 1 amount of times, okay, around, make full revolutions around the polar plane, and those are going to create different angles because we're dividing different values by n. And you're going to see that when we work out the example. Okay, so let's get in and check this out. For our fourth roots of 81 cis 120, what we're going to do is, first off, take the fourth root of the r, because that's what we saw right here. We said we're going to take the fourth root, or the nth root of r. Okay, so that's part one here. Okay, find the new r for each root, right? Okay, so again, the r is going to be found by the fourth root. That came out funny. Let me fix that. Fourth root of 81, which nicely is a perfect fourth power. So we get something like this. Comes out to be 3. Okay, so that's going to be our new r. Every time we're going to have a 3. Although the thetas are going to change. So all our answers, our 4 answers, are going to be in this form. And we know what the r is right now. Step 2. We need to find the new theta for each root. Okay, so for example, for our first root, we're going to call that theta root 1. Okay, theta root 1 is going to be, you're going to take the 120 degrees and add on 0 360s. Okay, because remember our theorem says, okay, you're going to add on 360 degrees k amount of time. So k being 0, then 1, then 2, all the way up until you get to 1 less than the root number. Okay, so we're going to do that divided by n, which again is the root number, so or is the amount of roots. So if we do that, 120 over 4, that works out to be 30 degrees. Okay, so our first answer is, if I may write that over here, root 1 has an r of 3 and a theta of 30 degrees. So let's go 3 cis 30 degrees. That's our first root. And we're going to proceed to do this for the other 3 roots. So for root 2, we've got our original theta, 120 degrees, plus this time k takes on the value 1. We're going to add on 360 one time and see where that puts us. Okay, so if we add on 360 one time to 120 and divide by 4, that gives me 120 degrees. So now I have a new root, root 2, which is 3 cis 120 degrees. See if you can now figure out roots 3 and 4. Pause and play the recording when you're ready. Okay, so I'm going to proceed to find out these final roots. Okay, so we're going to add on 2 full cycles to our theta and then divide by 4. That's going to produce a new angle. Then we're going to add on 3 full cycles added to our theta, and that's going to divide by 4, give us 300. So we have these other roots that are going to show up here. Okay, so again, we could display that graphically. If we're speaking about where these roots would appear, we might have something like this. This is our imaginary axis and our real axis. Imagine a radius of this circle of 3. Well, 30 degrees would appear about here, 120 here, 210 here, and 300 there. Those would be our 4 roots, W sub 1, W sub 2, W sub 3, and W sub 4. And so again, the important thing to recognize is once we have our first root, we're going to be adding on 90 degrees each time, right? So we got that first root of 30. We're going to be adding on 90 because that's 360 degrees divided by 4, the n. So we added on 90, add on 90, add on 90. 30, add on 90, 90, 90. Thanks for watching.